Hello everyone, so in this video let us talk about the D problem from the AD Coder Beginner Contest 300. Problem D, that is AABCC. Okay, this problem statement goes like this, that you have to print out how many positive integers not greater than n can be represented as a square into b into c square with prime numbers a and b such that a is smaller than b, b smaller than c. So in simple terms, you have to just find out, you are given some n. Okay, you have to just find out how many possible, like you can say, prime number combination a and b are there such that a square into b into c square is less than n. Okay, that's the overall thing. Now you just have to first find out all the prime numbers which are like under this condition. So you have to find out a lot of prime numbers that will follow this condition, and because it is like a square and it is also multiplying, it is pretty large number as well because it's prime number as well. So though it is large number, but still we want primes. So the very simple way to generate a lot of primes until a very maximum condition is, you can see sieve, the sieve method of generating primes. So if you haven't know the sieve of Eratosthenes method to generate all the primes, you can check out other videos as well. But you can do that to generate a lot of primes till at 10 to the power 6. That is sufficient because it is 10 to the power 12. So we can at least do that. And then what we can do is, then using those primes, we can just do a direct for loop, like a brute force 3 for loop, to just generate like whether we'll try to take every possible prime number among all the prime numbers that we have, and do a brute force to just check that whether choosing any three prime numbers is under this condition, that a square into b into c square is less than n. We will keep on incremental count, and the adjustment of answer. Nothing much. It's just pure simple brute force over this complete combination, and then before doing that, you have to just find out all the prime numbers till 10 to the power 6. And yeah, that's the complete logic for this particular problem. Nothing much complicated. You just have to just directly move on to the implementation part. So let's see the implementation of it. Okay, so for that, you have to first understand the sieve of Eratosthenes. You can watch another videos on that as well. So what we have done is, in this solve function, we have to first find out all the actual primes, you can say, till n over 6. So what we'll do is that, in simple terms, what we'll do is that we will keep on doing a for loop, okay, till from 2 to n. And if it is not a prime number, like say if we have a number, if it's not a prime number, we'll push that inside some prime array, you can say that it is not a prime number, and then mark all the multiples of that as non-prime, because if 2 is a prime number, then all the multiple of 2's apart from 2 are not prime. Okay, so let's say 4, 6, 8, all of that. So you are marking all of them in some, let's say you have this bool, let's say array that stores out whether it is a prime or not. So for you're doing a for loop, if it is a prime number, push it inside an array and mark all its multiple as non-prime. And if it is non-prime, you will not do anything. That's it. That's the sieve, and you have now the array of all the prime numbers that is here. Now what we'll do is that we will just sort all these, and then what we directly just do here is that we can now just do a brute force over a, b, and c to just find out whether I have the answer or not. So this is the answer that will store here. Now what we'll do is that the first thing is that it is a square. So I'm doing, let's say, I, j, and k. So I represent a. So if we have a, so you have to first find out a square. And at every step, to make it more efficient, what we can do is that if just multiplying a into a, if it goes out of bound, because I just want this expression a square into b into c, c square. So we just want that expression a square into b into c square should be less than equal to n. All these combinations of a, b, and c, we just have to find out. Okay, so if I just multiply, let's say a is already very large, let's say a, like let's say n is 10 only, and a is already very large, let's say we are talking about 100. Let's say a equal to, let's say 7. So 7 to 7 is already 49, which is larger than 10. So why we just go on finding out another for loops for a and b and c, which is already like waste of time. So what we can directly just do at every step is that if we multiply a and a, we are just finding out for a and a. If it already exceed n, okay, then we directly just break out for this complete for loop. If it is less than n, okay, it should be strictly less than n, actually, strictly less than n. Okay, if it is less than n, what we'll do is, okay, now we have find out some a square value. Let's look for b. So we will just take another b and multiply it in this x, because x is actually a square. Multiply into this. Now we have got a square into b, and now just again check that it should be less than n. If it is greater than n, we just break out. Then what we'll do is that now we have a square into b. Let's check about c square. So for c, just do gradually one by one. So we will first check out that whether we'll multiply this one time. If it is, so this c square, because it is becoming very large now, so a square into b, which is fine. Now c is like prime of k number, because this is the k which is like c. We'll first multiply it one time. If this becomes, you can say, greater than n, we'll just break out. If it is less than n, less than equal, like if it is less than n, what we'll do is now we again multiply the next c. So let's like we are multiplying c gradually one by one, so that we will not go like because if we go out of bound, we just have to don't count it, and we don't have to do another like x, like you can say more x you can say we don't have to waste our time complexity just calculating out waste answers. So we can just directly break out. If it is not, if it is still under n, we can just multiply the next c and just again if it is under n. If it goes out of bound at any point, we just break out. Else, if we have got the answer, we just print out or actually increment the answer. In the end, we just print out the answer. I hope you understand that's the complete logic. Nothing much complicated here itself. We just have to first find out the sieve, first all the primes using the sieve, and then just do a for loop, brute force for loop over a square into b into c square, checking out at each stage that if it don't go out of bound, if it don't become greater than n, that is fine, and just print out the answer. If we have got some answer, then just print it out. That's the complete logic of the code part for the fourth problem as well. If you still have any doubts, you can mention it in the comment box of this complete like proper video. I'll see you in the next one. Keep coding and bye.